so it's going to go on page 34. So we've been talking about derivatives, right? And the derivative tells us what? Slope, right? So so now we've arrived to a crucial point in the study of calculus. That's why we don't want to skip it. Here's the definition of the derivative. And it looks all crazy, a little intimidating, but I promise you it's not that bad. So the derivative of f at x, so at a given point, is written like this, right? F prime of x equals the limit of f of x plus h minus f of x over h. So we did find the slope using something very similar to that when we were doing limits with it a couple of days ago. But I want you to see it specifically with the h in it so that you understand how this kind of all works together. So the process of finding the derivative of a function is called differentiation. So it was something I said yesterday. The derivative goes with differentiation. A function is differentiable at x if its derivative exists at x and is differentiable on an open interval a to b if it's differentiable on every point on the interval. Okay? If you are told to differentiate, let me make sure I spell it right. Differentiate. That just means take a derivative. Derivative. I can't spell either one. Okay. So if you were told to differentiate, it just means take a derivative. Can't say it or spell it. So we're going to do this for this one function. We're only going to do one because it is going to be a lot of writing and a lot of stuff, but it works for everything, but we're going to have some shortcuts that we're going to learn, then we're going to really like these shortcuts. So if this is f of x, we're going to find f prime of x. That's the derivative. And we're going to use this limit definition of the derivative up here. So this is equal to the limit as h approaches 0 of... Okay, and so we're just going to write down exactly what it says. F of x plus h minus f of x over h. Okay. So then we're going to, for this specific question, let's find f of x plus h. So f of x plus h means I take x plus h in my original function, and everywhere I see an x, I substitute an x plus h. So that would give me x plus h squared minus 3 times x plus h plus 1. Okay, everybody understand what we did there? Right, we literally just substituted that in. That's all we did. So then we're going to work this or multiply all this stuff out. So that means that f of x plus h equals. So if I square this, does that just become x squared plus h squared? No, it does not. So first thing is we know it's not that. So when we do, we square x, so we get x squared. Then you can multiply them together, x times h, and then double that, so it's plus 2xh, and then plus h squared. That's the pattern for that, or you can actually write them out and do your FOIL and whatever you need to do. Then we're going to distribute that -3, so I get -3x minus 3h plus 1. Everybody okay with that so far? Doesn't look real pretty, but it's okay. All right, so then can I combine any like terms there? Are there any like terms? No, there aren't any, right? They're all different. So we've got those six terms there. So now we're going to take that. We found the x plus h, and we're going to put it in right here. So we're going to write this is equal to the limit. Don't forget your limit statement. The limit is h approaches 0 of, okay, so my f of x plus h. I'm rewriting this whole thing right here. X squared plus 2xh plus h squared minus 3x minus 3h plus 1. Probably should have started that a little bit farther. And then I have to do minus f of x It's going to be a little leany. Minus, then my f of x, and that's more than one term, so it's in parentheses, minus x squared minus 3x plus 1 all over h. Any questions about where anything came from? Okay, so then that's going to equal the limit as h approaches 0 of, all right, so I'm going to look at this and I've got x squared minus x squared. Those zero out, right? So then I have 2xh. There's nothing I'm subtracting. There's not an xh there, so I just have 2xh here. And then there's only one h squared, rather, so plus h squared. So it's taking care of those two. So I'm marking them out as I use them because there's lots of them, right? So then I have negative 3x minus a negative 3x. What happens there? They cancel out, so they zero out right there. Then minus 3h, and that's the only h that I have, right? So I've taken care of that guy. And then I have 1 minus 1. Those zero out. So that's what I'm left with in my numerator. H is in my denominator. Do you kind of see where we're going with this? Can I simplify this part right here even more? What do I need to do in the numerator? Factor out. I'm going to factor out my GCF, so this is equal to the limit as h approaches 0. Oh, let's pause for a second. Why couldn't I have just substituted 0 in from the beginning for h? Because it was in the denominator, right? And I had a 0 in the denominator, so that's why we do all the rest of this stuff, and let's get rid of h in the denominator. So in the numerator here, I factor out this h. That's going to leave me with 2x plus h minus 3. You agree with that? Over h. So then what happens with these h's here? They cancel out. And now that we've canceled those out, now we can do, well, let's just go ahead and rewrite it. You wouldn't have to rewrite it, but I want you to lose where we are here. So then I have the limit as h approaches 0 of 2x plus h minus 3 once I canceled those out. Okay. Now that I've canceled those out, I've simplified it as much as I can. Now I can do direct substitution. I substitute 0 in for h right here. And since I'm substituting and doing my direct substitution, now is when I get to drop this limit statement because I'm taking the limit. So this is going to give me 2x, then plus 0. So I'm not going to put that. It's just minus 3. So what we have just found here is f prime of x equals this right here. 2x minus 3 is the derivative of x squared minus 3x plus 1. Okay? So if we write over here, corner off our spots here, f prime of x is equal to 2x minus 3. So if we want to find we'll find the slopes at these given points. So let's say I want f prime of -1. I substitute -1 in there. -1 times 2 minus 3 is -5. Agree with that? F prime of 0 is going to be -3. F prime of 1 would be what? What did I get? What? This one? I just want to find f prime of 1. Why would it be 2? Oh, because it is, oh, it says it up there. Huh. Never mind. I wanted to put 1 in there. Sorry, I didn't realize it actually said that. I thought I was just, yeah, I want that one too. And 1. Because I said so, because we want to look at them. And 1. So yes, I got it from my brain, sorry, because yeah, I'm not really making things up, but all right, so when I do 1, that gives me -1, right? And if I do 2, then I get 1. So the reason I wanted to do that is because we want to look at this graphically, but just with a sketched graph, okay? So your original function when you graph this thing, this original one, what's it going to look like? It's a parabola, right? Because it's a quadratic. All right, so we're going to sketch that right here. I'm going to tell you where some of the estimated points are. Okay. So let's make just like 1, 2, 3, 4 semi-evenly spaced hash marks the best you can, and then we'll just kind of put 1 up there. So your y-intercept is 0, 1. One of your zeros is at about 0.4. Another one is at about 2.6. Okay, they don't have to be perfect. We're just, and then I should have made a negative one down here also. And then the vertex is at about 1.5, negative 1.25, so kind of right there. Just so we have a basic idea of the shape. It's fine that it's not perfect, okay? So then we'll sketch in a parabola here. A hard time on this board. Something sort of like that. Although it's straighter than I would like it to look, but it's fine. Okay, so let's think about what these values we have actually gave us, right? Because the derivative tells us the slope. So when f is at -1, so -1 is about right there, right? When x is -1, the slope of the parabola is -5. So that's the slope of the tangent line, which we could draw in kind of like that. When x is 0, the slope is -3. When x is 1, the slope is, I'm trying to get it on the other side of it, but on this board, my pen does not like me. Okay, so do you see how this is -5, then -3, then -1? You see how the slopes are decreasing? It's kind of what I wanted you to see there. So what is the slope when x is 1.5? 0, okay, because you would have this. That's not something that we found, but it would be 0 if we put it in there, and we can go look at that. So then that's why I wanted you to have a 1, and then 2, we're here at +1. So you have that -1, and you have the +1 for the slopes. The slopes become positive. So that's what's happening there. And if we substitute in 1.5, well, 2 times 1.5 is 3 minus 3. That gives me that slope of 0. Okay, so I just wanted you to kind of tie it to that visually. So we've already talked about the fact that the derivative gives us the slope of the lines, but we hadn't done one like this. But one of the reasons that you want to do something like this is if you look back at this version of it before we marked everything out, and you don't necessarily have to circle yours, I'm sure your paper's a hot mess by now too, but if I give you this right here, okay, if I just gave you everything that's written in purple that I just circled in yellow, and I asked you what is f of x, if you have never seen this type of thing before, you wouldn't know what the heck to look at, right? But this part right here is your f of x. Make sense? And then if you know your shortcuts, then you can easily find the derivative without doing all this other stuff that we just did, okay? So the reason we only did one is because we don't have to do things the long way every single time. But you at least need to understand how they get set up, and we'll look at more questions like that for sure. But that's one of the reasons that it needs to be in your brain somewhere. Okay, and then we'll get to the shortcuts. And we'll come back and kind of look and see if you can see any ties between those two. This right here, I believe, is already on some other notes, but I just left it on this page. But it's how you read the different ways you can do this, right? You could see the derivatives in all 4 ways, which is the way that you really shouldn't be writing it. Do you remember? One of those 4 ways. Not recommended that you do it. Y prime, it's this one, okay? You might see it, but there's reasons why you don't want, that's not how you want to be writing things. Okay. So then we have an alternative definition of the derivative. Instead of doing f of x plus h right there and h approaching 0, we can do it approaching an actual number, like put the number in there to begin with. And as long as the limit exists, this is an alternative version. And just know that there is an alternative version. We don't want to neglect that guy. When we come back and look at questions where it gives you this and you have to decide from that what f of x is, I'll kind of give you some hints on how to look at that. But I wanted this all in one place. Okay? We good with that right now? So here's the good news. What we just did, you don't have to do every time because we're going to talk about the rules that allow us to not do that. And I left a piece of paper on my table on the desk apparently. Let me give you this one. So the first thing, and probably one of the easiest rules for derivatives, is the power rule. Well, give me 1 second here because I have lost my paper now. Okay. So what page is this second one going on? 35? Okay. Here we go. This is going on 35. Okay. So we're going to start with the power rule, which is going to help us with polynomials and some other things. All right, but we could definitely have used the power rule on what we just did. But again, this is the actual definition of a limit, okay? So the process above is the limit definition of a derivative. As you can probably remember from 5 minutes ago, the process can be tedious. So we don't want to have to do that on everything. So here's our rule. So your power rule for the derivative, if f of x equals x to the nth power. So that's not an exponential, that's like a polynomial type situation where the exponent is a number, not a variable. Then what we do is this. Whatever the exponent is, so that's n, it comes out in the front, n times x, and then the exponent becomes n minus 1. This only works for powers of x. And make sure that x is in the base before you use the power rule. That means make sure x is not in the exponent. You can't do it if it's an exponential. Okay? So for each one of these, we're going to find f prime of x and f prime of 3. Okay, so let's look at how this power rule works. So for a, f prime of x, we take the exponent, which is 3. It becomes the leading coefficient. I still have an x. And then I subtract 1 from the exponent. It becomes 3x squared. It's that easy. Okay? You good with that? Now that's f prime of x. Let's find f prime of 3. Then you just substitute it in there. It's 3 times 3 squared, which is what? 27. Okay. All right, so let's look at B. I'm going to take this 2 that's in the exponent, so it's f prime of x. It gets multiplied in the front. There's already a number here. There wasn't one here, but there was a 1, right? So I did like 3 times 1. So I'm going to do 2 times negative 3. That gives me negative 6 times x. I subtract 1 from the 2, and it's just a 1, which you wouldn't have to actually put, right? And we wouldn't actually put. I just want to make sure you understand that that's what it looks like. So really, negative 6x. You would not have to write this step, but I want to make sure that you understand where everything's coming from. So then I want f prime of 3. So that's equal to negative 6 times 3, which is 18. Negative 18. Everybody understand how that works? Okay. So then or f prime of x on c, what do you think the derivative is? What's the exponent on the x? 1. So I do 1 times 5, which is 5, times x to the 0 power, right? What's x to the 0 power? 1. So this is really just 5. And again, you don't have to write this step, but it's not a bad idea to have it in your notes when we're first learning it so you know where the heck everything's coming from. So then f prime of 3, what do you think that is? It's just 5. Because here, if this is my derivative, my rate of change changes, right? Here, my rate of change is constant, so f prime of 3 is 5. Okay? We okay with that? All right. So let's look at D. We have f prime, no, that's it. Oh yeah, I don't have to write D. F prime of x, all right? We're going through the same process. So I do -2 times 5, that gives me a -10 times x to the what? -3 power. Now, your x to the -3, what does the negative exponent do? It moves it, that's a fractional one. We're going to get there. Okay, it turns it into a root. But the negative ones just tell you it should be in the denominator. Yes, like the reciprocal, yes. So this is the same as 1 over x cubed. So that means that here I've got -10 over x cubed is really what I have there. Okay, because x to the -3 power is just 1 over x cubed. Okay, we okay with that? All right, so then f prime of 3 is equal to -10 over 3 cubed. What is 3 cubed? 27. So this is -10 over 27. Can I reduce that? No, I cannot. Okay. We good so far? Understand and remember our exponent rules? All right, so let's look at E. F prime of x. What do you think that might be? Well, I don't have an x there, right, like I did in all the rest. So what if I put one here? What if I said this equals 7 times, what would the exponent on the x have to be? 0, so that I don't change the value, right? So if I look at it that way, and I take the derivative then, what's 0 times 7? 0. And then that would be 0 times x to the -1. Does that x to the -1 even matter? No, it's just 0. So the derivative of a constant is 0 every single time. Okay? Which means then that f prime of 3 is equal to 0. Now let's take a look back over here and think about what we just did, right? So we had, I don't really have any room to write, but if I have this, and I'm just looking at this right here, then my derivative, f prime of x, we're going to use our power rule. 2 comes out in front, so this is 2 times x to the first, right? That's what I would do there. There's like a 1 there, so 1 times -3. Oh, and you don't necessarily have to write it on yours. But you can. I just wanted to show you. I'm sorry. So this gives you, that would give you a -3, right? And then the derivative of a constant is just 0. That's my derivative using the power rule. That's what we found using that x minus h stuff. Okay? But because we know the power rule, we don't have to go through all this every time. Okay? Yeah? See? So this just becomes 2x, bring that down there, 2x minus 3, and that's it. Okay? That's why we're doing it. So, I mean, if you want to write it on there, you're fine. You didn't have to necessarily dig it back out. But it's the same thing that we found over there. Okay? You see how that works? And that's way better than doing all this, right? But again, this has a purpose. That's why we did it. Otherwise, I wouldn't have made you do it at all. Okay, so let's go back over here. Look at some other things that could pop up. I've got this 2/3 times x to the 4th. That's the kind of form you want things in, right? That's the same as 2x to the 4th over 3, right? But we don't want it as 2x to the 4th over 3. We want it as 2/3 times x to the 4th, so that when I take the derivative, I'm going to multiply 4 times 2/3, right? So that becomes 8/3. Would you agree with that? Times x cubed. And then leaving it like that is fine. We want f prime of 3. So this is going to give me 8/3 times 3 cubed. Right. What is 3 cubed? 27. So that gives me 8/3 times 27. I really don't want to multiply 8 times 27. Do I have to? No, because I can reduce this, and this becomes 9. So overall, this becomes 72. Right? I could multiply and then divide, but it's better to reduce it as you go. Questions? Got it? Okay. All right, let's look at G. I want to rewrite G. Okay? I don't like the way it looks. I want it to look more like F did. So this is the same thing as 1/6 times x to the 4th. And we're going to have some other rules that come up. This is just the very first one. So we're going to have a rule for what happens if we have variables in the numerator and denominator. And we could use that rule for this also, because I have a numerator and denominator, but it makes this more complicated when it doesn't need to be. Okay? So here, now that I have it like this, f prime of x, I multiply 4 times 1/6, which we can write it as 4/6 times x to the what? 3rd. Now, leaving it as 4/6, not the end of the world, okay, and not wrong in the calculus world, but usually it makes it a little bit better and easier for you to use if you actually reduce it. So we can reduce this to 2/3 x cubed. Okay. So then when I want f prime of 3, I'm going to get 2/3 x, no, that would not make sense. I need to substitute it in, times 3 cubed. Now let me ask you this. Could I reduce before I ever get to the 27? Isn't this 3 to the 1st and that's 3 to the 3rd? Now, I don't want to confuse you or make things worse, but it can be helpful depending on the numbers that you're using. If I want to divide this 3 out with one of these, I can change that to 3 squared, right? Because that's what would happen anyway. You'd have 27 divided by 3, you get 9, right? So now it's just 9 times 2, which is 18. You can write it out like that. You don't have to. If you don't feel like you would do that right, don't do it. But if you get what I just said, then that's fine too. Okay? It's okay to be at different parts of that. All right, so let's rewrite h a little bit, because I don't want x in the denominator. So I'm going to rewrite this in 2 steps just so I don't lose anybody. This is the same thing as 3/2 times 1 over x to the 4th. Would you agree with that? Okay, so I got my coefficient out, and then I have 1 over x to the 4th. But I still don't want x to the 4th in the denominator, so this can become 3/2 times x to the what? -4. Very good. Okay. Everybody understand how we got there? You want to take the time to do that before you take the derivative. It will make your life easier. So then I have f prime of x equals, so -4 times 3/2 is -12 over 2 times x to the what? -5. Good, because we're subtracting 1, right? So what's -12 divided by 2? negative 6. And so this can become negative 6 over what? X to the 5th. Right? Or you can do it times. Yes, negative 5 is an acceptable answer. So that's a very good question. Yes, you could leave it as this. However, I highly suggest when you go to evaluate it, like we're going to do in the next step, to write it like this so you don't go do weird things. Okay? I think it's going to help you. Definitely helps me to actually write it like this so I don't do strange things with the exponent. But yes, it is acceptable. That's a good question. All right, so then I have f prime of 3 equals, so this gives me negative 6 over x to the 5th. Oh my, why do I keep doing that? 3 to the 5th. We're substituting it. 3 to the 5th. Now, let's do what we did in the question before this. Now, if this was the final answer, I could leave it like this. That would be fine. That's acceptable. All right? But I don't really want to have to do 3 to the 5th if I don't have to. So what I could do is I could divide a 3 out, right? I could make this negative 2 and this to the 4th power. That makes sense? I just took a 3 out of the numerator, 3 out of the denominator. Does that make sense or no? And I shouldn't do it that way for you. Okay. Kind of does. Now you can multiply it out. I saw some of you back there doing that, and there's nothing wrong with that. Okay? But if I do it this way, now I have negative 2. I know 3 to the 3rd is 27, so then I just have to do 27 times 3, and what's that? 81. Otherwise, I'd have 81 in the numerator. What's happening, I'm sorry, 81 times 3 in the denominator. What's happening here, just because I think I kind of lost some of you, this numerator, another way to look at this, is negative 3 times 2. Would you agree with that? And in the denominator, I have 3 times 3 to the 4th. Right? And then that would be 3 to the 5th in the denominator, right? So I'm kind of splitting it up like that, so then the 3's cancel out, and I have what I had in blue. Okay? But again, you don't have to make things more complicated and potentially risk messing something up, because if this was a multiple choice question, you leaving it like negative 6 over 3 to the 5th would probably not be an answer choice. It would probably be this, so we still have to know how to handle it. Okay? We're okay with that? All right, good deal. Okay. Let's look at I. So I would like to well, how do you think we want to rewrite this? Yeah, 3/5 times x, right? So 3/5 times x, and if it helps you to put the 1 on it, put the 1 on it. Okay? So then when I do that, you don't have to, but if that 1 helps, it might at the beginning especially. I'm going to get 1 times 3/5, that's 3/5, times x to the 0. Well, what's x to the 0? It's just 1, so I don't even need to put it, right? Put it on the one of the ones up there just so that you knew what was happening, but it's literally just 3/5. Okay? So what is f prime of 3 then? 3/5. Very good. All right, so we are going to rewrite these, and then I'm going to let you work on those, and we'll start there tomorrow. So let's just rewrite how we would want it. I don't want 1 over x. How else can I write that? X to the negative 1 plus 2x squared. Okay? And then I can take the derivative of that. On k, I would rewrite this as, this first term would be what? X to the negative 2, good, minus 2 times x to the what? Negative 3, good, and then plus 3x minus 7. So when you take the derivative of those, I want you to take the derivative and then put whatever needs to be back in the denominator when you clean it up, okay? So y'all work on those. I mean, I know you only have like 2 minutes, but I want you to actually do an attempt J, K, and L before tomorrow, okay? And then we will start here tomorrow and finish up the rest of this, okay? We're good? Okay. J, K, and L. J, K.